So if you'll also turn to page 279, 279 is where 6.1 starts. And it tells you that there's this online activity here. And so that's what I want to walk you through today. When you log into Reveal, on like the left-hand side under the calendar, it'll say 6.1 write and solve one-step equations or whatever. Click on that and then click View, and then you'll see a big orange like Explore bar. You should be able to see that big orange Explore bar then under the left side of the calendar, or once you're into the thing. Oh yes, so write and solve one-step equations. And then there's like a green tab under Launch that says Explore and Develop. We're clicking that, and then right below there is the big orange Explore thing. So this is just going to kind of walk us through the thing here. So if I think, so here, well, it probably looks like this. Will it take me home? Country road? Yes. So when you click on it, you should see, sorry, for whatever reason my Zoom wouldn't work, so I just have to talk you through verbally. You can view here, click that, and then under the Launch tab, there's an Explore tab. You might have to click that before it opens up to this. Maybe it's a little slow. All right, so it's just gonna walk us through here. There. How can algebra tiles help you solve one-step equations? So click over on the top to 2 of 7. You can use algebra tiles. So how to use it? You can add or subtract 0 pairs from either side of an equation without changing its value. What equation is modeled on the mat? All right. So this is x plus what? How many ones are there? 4. So we have x plus 4 is equal to what?
4.
No. X plus 4 is on the left. Look at the screen. Is equal to -5. Good. We have 1, 2, 3, 4, 5 negatives. So we can try and figure these out. So we have to get x by itself. So how do you think I would get rid of a positive x? With a negative x. So when I move it over here, instead of just moving it over here, I have to replace it with a negative x. So every time I get rid of a positive x on the left, I can probably put them back here, huh? I have to grab a negative x from the right. Every time I get rid of a positive x from the left, I end up with a negative x on the right. And every time I get rid of this last one. So in other words, they subtracted those 4 from both sides of the equal sign. Is -4 equal to -4? Yes, so they just kind of combined like terms, and we ended up with x equals negative what?
9.
-9, excellent. So then, looking here, on 3, it's just walking you through that. Use your plan to isolate the x tile, which is what we did. All right, so now they're giving us x minus 3. So I have an x on the left, and how many of these negatives? 1, 2, 3. So I'm on 4 of 7 if you're following along in Reveal in the Explore section. And then on the right side of my equal sign, I have how many negatives? 2. So in order to get this x by itself, I have to make all of these negative ones 0. How do I make a negative 1 0? I add a 1. So if I add this 1 over here, whatever I do to that side, I have to do to this side. If I add this 1 over here, whatever I do to that side, I have to do to this side. And I have to add one more 1. So now, anytime we have a negative 1 and a positive 1, it is 0. So these should go away. So it gets rid of those, and I have to simplify this side too, because anywhere where there's a negative 1 and a 1, it equals 0. So what does x equal? X equals 1. Does that make sense? Does 1 minus 3 equal negative 2? Does 1, if I put 1 in for x, because we're saying x equals 1, does 1 minus 3 equal negative 2? Yes, it does. So that makes sense. So what equation is modeled on the mat? So we have, oh, this is a little bit trickier. This is kind of what we're going to get into with multiplying. So this is 2x, because we have 2 x's, and how many negatives? 8. So this is actually kind of nice, because if each x is equal to half of these, we're kind of like 1x is equal to what? Negative 4. If 2 x's are negative 8, then 1x is negative 4. So they're really dividing by 2. And this one I think is a little bit harder to show than addition, subtraction. I don't know. And so they want you to do the same thing with this. So if we have 3x, so 1, 2, 3x on the left, and that's equal to negative 9, well, I'm going to kind of count to 9 and rearrange each one of these in line with one of my x's. Will that work?
3.
Exactly. And so it's not positive 3, but it is negative 3. So x is going to equal negative 3. Good eye. See, sometimes this more concrete stuff helps us see it, and then we'll teach you how to do it arithmetically. Yeah. I'm glad we spent a minute on these algebra tiles. I just wish Zoom would work, so this would be part of the video too, so you'll kind of have to walk through it on your own. All right, so with that being said, I'm going to close that. You can close your Chromebooks, and we'll start kind of taking a little bit of notes, starting on page 279. So we just did this Explore thing online. It says properties of equality. I know it's really hard to see up on the screen, but hopefully you've got your book in front of you. Addition property. 2 sides of an equation remain equal when you add the same number to each side. Same thing with subtraction. So in order to keep our equation equal, whatever we do to the left side, we have to do to the right side. Now this is a little bit different, right? With fractions, we could keep equivalent fractions, but only by multiplying or dividing the top and the bottom by the same thing. Now, to keep our equation equal, we can add and subtract, or we can multiply and divide. But whatever we're doing to one side, we have to do it to the other. And that is just what those properties of equality are explaining. 279. So they're telling you that if A is equal to B, if we add something to A and the same thing to B, if these are all numbers, then it will keep it equal. Or even if they're not numbers, right? Yeah. If A is equal to B, if we subtract the same thing from both sides, it would stay equal. If A is equal to B and we multiply the same thing by both sides, it would stay equal. And same thing with division. If A is equal to B, we can divide both sides by the same thing to keep it equal. Okay? So I'm turning to page 280. Those notes are there for you to refer back to. So the equation, we have to know what an equation is, right? A sentence stating that two qualities are equal. So saying something is something else. So a lot of times in place of the word is, we use an equal sign. The value of a variable that makes an equation true is called the solution of the equation. So when we were finding out what 1x was equal to, that was our solution. So here, the equations x plus 2 equals 6 and x equals 4 are equivalent equations because they have the same solution, right? So they subtracted 2 from both sides and then ended up with x equals 4. And they kind of show that with the algebra tiles there on 280. All right, so now, just like all things math, you have to keep neat and you have to show your work. So looking at example 1 rather, it's going through how you would show this work. They rewrote the equation. Then below the constant on the left and the constant on the right, they wrote minus 8. So they have negative 5 minus 8. What's negative 5 minus 8?
3.
Negative 13. They're both negative. Signs are the same. Find the sum. We're refreshing that with our 8th graders too, so don't feel bad. And then, what is 8 minus 8? 8 minus 8 is 0, right? So that's why we subtracted 8 from it. So we were left with b on the right. So then if we put that solution back in, so we would say negative 5 is equal to, we said b was negative 13, so I'm going to put it right here. So that's what I'm putting in my box. I do have some pencils up here if you don't have yours with you. So what is negative 13 plus 8? We're on page 280. Whoops. So negative 13 plus 8 is negative 5. And if negative 5 equals negative 5, then this sentence is true and our answer is correct. So they're just showing you how you would check your work. So here we go. Are you ready? First thing I'm going to do is write down my equation when I'm checking. Negative 7 is equal to x plus 4. I'm sorry, I was writing 7 and saying 4. X plus 4. How do I get rid of that positive 4 that's connected to the x? I want it to be 0. I add negative 4. Just subtract 4, right? Either way, it's saying the same thing. So if I subtract 4 from the right side of my equal sign, I also need to subtract 4 from the left side of my equal sign. Do you see that? So be sure you're showing that work nice and neat. Kendra, do you need a pencil? Okay. Your legs work, right? So what is negative 7 minus 4? Well, our signs are the same. So we find the sum. What's 7 plus 4? 11, but it's going to be negative 11. No, not 3. Our signs are the same, so we find the sum. I know. And then I bring my equal sign down. I have an x there. There's no like terms I can combine with the x. And 4 minus 4 is 0, so that goes away. So what does x equal? Negative 11. And if we check that, we would rewrite negative 7 is equal to negative 11 plus 4. So really think it through, though. Our signs are different here. So 11 minus 4 is 7, and my bigger number is negative. Negative 7 does equal negative 7. So this solution of x equals negative 11 does make my equation true. So do you notice that if we're adding something to x, we have to do the opposite of it? The opposite of addition is subtraction. Now, in example 2, we're subtracting something from x. So I'm jumping to page 281. We're subtracting something from x. So to undo subtraction, we have to do What's the opposite of subtraction? Addition. All right. So here they were subtracting 4 from x, so we had to add 4 to both sides. So they said x is equal to negative 2 plus 4, which is 2. Then they put 2 back in to check it. Negative 2 does equal negative 2, so the solution of the equation is x equals 2. So that's what we're putting in the blank there, and then we need to check. So I'm redo the check, rather. Q minus 8 is equal to negative 9. So here, how do I make that negative 8 a 0? If I subtract it, I'd have Q minus 16. What's the opposite of negative 8? Positive 8. So I have to add 8 to both sides, right? Because 8 does equal 8. So here I have Q. Negative 8 plus 8 is 0, so that goes hasta la bye-bye. I bring down my equal sign. Negative 9 plus 8. My signs are different, so I find the difference. My answer is not quite 1, but it is negative 1, because my bigger number was negative. All right, so then to check that, I would say negative 1 minus 8 is equal to negative 9. Well, negative 1 minus 8, my signs are the same. I find the sum, 9, it's negative. So negative 9 does equal negative 9. It checks out. My solution is correct. So here's my solution. Okay? Now, just like addition and subtraction are inverse operations of each other, multiplication and what are inverse operations of each other? Division. Good. So when we have a letter, you might want to write this down. Letter next to a number, that means what? What's being done to y? What operation is that? Multiplication. Good. So letter next to a number is multiplication. That snoring's going to be on camera. All right. So negative 8 times y is equal to 24. So in order to make that a 1y instead of a negative 8y, if we divide it by itself, it would be 1. Negative 8 divided by negative 8 gives us 1y, right? So they're dividing both sides by negative 8. Well, we write 1y just by writing y. So we don't even have to have the 1 there necessarily. But what's 24 divided by negative 8? Close. 24 divided by 8 is 3, but our signs are different here, so it is negative 3. So then they put in that y value in place of y. Negative 8 times negative 3 is indeed a positive 24, so the sentence is true. 24 does equal 24, so the solution is that y equals negative 3. Okay? So we undo addition with subtraction, we undo subtraction with addition, we undo multiplication with division, and we undo division with multiplication. Okay. So let's check your work here. How do I make this 1a? What do I have to divide both sides by? The coefficient. Remember that term? No. The number in front of the letter is called the coefficient. So we have to divide both of these sides by the coefficient. What's our coefficient of a? Negative 6. And don't forget that negative. Excellent job. So negative 6 divided by negative 6, this becomes 1. 1a we write as a. We bring down our equal sign. I need to be sure I'm showing my work that I'm dividing the 36 by negative 6. Well, what's 36 divided by 6? 6, not subtracting. So 36 divided by 6 is 6, but our signs are different, so it's negative 6. So then if I were testing it, I would say negative 6 times negative 6 equals 36, which is true. 36 does equal 36. All right. So before we did this check, you guys told me that to undo division, we had to do what?
Subtract.
To undo division, we have to multiply. Very good. So they did this a little bit backwards. What I would usually do, instead of rewriting it even, I would put parentheses around my left side, put parentheses around my right side, and then write what I needed to multiply them by. So whatever I'm dividing by, I have to multiply them by. Because remember, when something is divided by itself, it equals 1. So that gives us 1a in this case. So what is negative 4 divided by negative 4 is 1. So we have 1a on the right. But what's negative 4 times negative 9? What's 9 times 4? 36. And it's positive because our signs are the same. So then you would check your solution. 36 divided by negative 4 is negative 9, and negative 9 does equal negative 9, so it's true. So I'm going to rewrite this one, y over negative 3. So that, remember that fraction bar means divided by. To undo division, we're going to multiply. So I put parentheses around both sides. Hard to keep up when you're fooling around, so stick with me. So after I put parentheses on both sides, what am I multiplying by? What's in the denominator? What's y being divided by? Y is being divided by negative 3. So I have to multiply both sides by negative 3. So negative 3 divided by negative 3 is 1. 1y I can write as y. And then I have negative 8 times negative 3. What's negative 8 times negative 3? 24. And it is positive because my signs are the same. So if you wanted to check that, you would say 24 divided by negative 3. And you should come up with negative 8 does equal negative 8. Cha-ching. So y equals 24 is the solution to that. Okay? So just a little bit of practice today, undoing addition and subtraction and undoing multiplication and division. So it looks like you can do 1 through 8 on page 287. So we're skipping to page 287 and doing 1 through 8. Now, I don't like the way they kind of set this up, but you guys know the opposite of a positive number is what? Negative. So if I have a positive 6, I need the additive inverse of that, right? So how do I make that 6 0? I have to add negative 6, or you always say it like that, I like that. Or you can subtract 6 from both sides. Right? Because 6 minus 6, that gets rid of it. Yeah, same thing, right? It's subtracting a 6. Perfect. All right, so we have y is equal to, our signs are the same. What's 8 plus 6? 14. And it is negative. Good. All right, so that's kind of the same way you're going to do this other one. Just because our letters are on the other side doesn't mean it's changing. What am I subtracting from both sides in number 2? How do I get that 4 away from the C? Subtract 4 from both sides. Okay? Or add a negative. And then the next two, you have to undo negatives. So you're going to be adding those. then you're going to be dividing, and then you're going to be multiplying. So just a little bit of practice there. We got over 10 minutes. I think you can handle that. I'll be wandering around. So make sure you finish 1 through 8 before you close things up for the day.